In this section, I'm going to introduce threats, attacks, and vulnerabilities. Threat is an event with the possibility of violating the security rules. It could be intentional or it could be unintentional. So hacking could be something intentional threat, accidental event or a malfunction could be unintentional. Attack is a deliberate exploitation of a discovered weakness in a computer system. Attacks can be categorized into either passive attacks or active attacks. Passive attacks is where system is monitored for vulnerabilities. Active attacks where hackers exploit the system. And then the vulnerability is a weakness that makes the target susceptible to attack. In other words, it's a known weakness of a resource that creates a threat, which hackers can use to attack a system. The challenges you see in IoT domain, especially related to security, is somewhat similar to the challenges that you see in IT environments, but it also have new dimensions which make the security much more difficult. Because IoT has large number of devices and heterogeneity with all the devices being connected to the internet using different protocols and different intermediary nodes. So there are a lot of distributed attack surface that you need to protect. In this slide, I have put a video which shows how to attack a smart irrigation system. Probably you don't know exactly what the botnet is. We will be talking about that in a later slide. But just have a look and get a feeling what cybersecurity attack means and how that can be performed. Over the next few slides, we are going to talk about 5 common cyber attacks. Botnet, man in the middle, data and identity theft, code injection, and distributed denial of service. A botnet is a number of internet-connected devices where each runs a bot. Bot is a piece of software that can be used to program some task repetitively, especially to improve efficiency or doing some maintenance task automatically. For example, they are used to relay internet chats to maintain the consistency and the experience. So the technology or the concept of bots can be used for good purposes or bad purposes or malicious activities. So in this case, each of these devices is compromised with malware or malicious software. And then malicious software is using these individual devices to do some harmful activities. So this malware could be installed in each of the devices, and they hijack the device and get the control of it. And then they can use these devices to perhaps conducting DDoS attacks or sending misappropriate data, conducting email campaigns, spamming, or any other activity that is fairly simple enough for a software program to do, especially repeatedly. In a bot network, there is a controller, and then the malicious party, as you can see in the figure, would send the commands to the controller, and then the controller, again a compromised device, will send the messages to the other compromised controllers. And these compromised devices will do the particular malicious activity as instructed by the controller node or the controller bot. One of the well-known attacks that uses botnet is called Mirai. Happened in 2016, which uses a lot of different IoT devices to create DDoS attacks, which means that each of these IoT devices send a random spam request from other web servers, and then because there are large numbers, then the servers cannot respond to everything, and then the legitimate users will not be able to access the particular web service. Mirai started compromising IoT devices ranging from CCTV cameras, routers, baby monitors, and other IoT devices. And then they become the zombies and then act as the bots, send requests. To understand how the botnet uses to DDoS attacks, please watch the video I put here. The next type of attacks are man-in-the-middle attacks. This type of attacks are attacks where impersonation happens in the middle, where they would the malicious party would intercept the communication between two nodes and steal information such as authentication details or any kind of data. In a potential attack, a malicious party would capture part of the communication, usually login credentials, and replay to the bypass the authentication phase and access the system. So basically, they can either read the information or use that information to access the particular resource, or even send a false information by fabricating it. An example scenario would be the malicious party would intercept data packets going in between control center and the IoT sensors, and change in such a way that it would mislead the control center and will do damage to the physical assets. For example, a fake information or altered information about soil moisture can cause overwatering and flooding a particular area. Or if you change the values coming from a temperature sensor, you can burn down a factory in a manufacturing facility. So there are a lot of harm someone could do if they are able to change the readings, especially sensor readings coming from sensors to the control center. In traditional web domain, people have always used this kind of attacks to steal the login information and pretend they are the account holder when they're doing online e-payments. And especially in web domain, when the malicious party get access to the login information, they probably can access the other accounts that are linked to the particular account, or if they have using the same credential, they could use completely different services as well of the victim. To better understand how the man-in-the-middle attack works, please go and watch the video. Identity theft is the deliberate use of someone else's identity. These happen offline as well. You can steal someone else's personal information and use that information to buy phone cards or any other services where people ask identity. So like if you have someone access to bank statements or identity card, you can steal them and then you can use it to places where identity is asked and pretend you are someone else. This happens online as well when you're accessing services which ask for identity information. If you have sufficient information about your names, details, or any other secret questions that you input in a previous time to a particular online system, people can pretend you are, because sometimes even these double authentications where you get a message for your phone number. So if someone can intercept that phone messages and have your names and emails, the more information someone has about you, there's a better chance they could pretend your identity. Increasingly, this is become an issue in IoT where the security configuration, especially the default configurations, are much weaker. They use same passwords or unless the user reset them. Anyone could know what is the default password, and more likely the manufacturers don't force the people to change the password, so end users might keep the same password. And also, if you store your information or you input information to that particular account, and if that particular IoT device or the account get exposed, potentially the same information could be used as your identity to use in some other places as well. Typically, in order to steal your identity, the attacker needs to collect large volumes of data about you. But once they have them, they can pretty easily go through any identity checks by using your information, even without you knowing it. In order to understand identity theft, please go and watch the video I put here. Code injection is the next type of attack we are going to discuss. Basically, what attackers do is they submit a malicious code to your system when you provide an opportunity for the end users to provide an input. For example, if you are allowing them to enter their name or any kind of input that can enter some information manually rather than selecting like combo boxes or any date pickers or anything like that. As long as you provide something that they can manually type, they, instead of typing their real name or age or something like that, they would write a complex code. And then if you don't validate it, they can actually guess what is happening inside your code. And then they can get it executed in your server, and then maybe even delete your databases. It would be much clearer what I'm talking about once you watch this SQL injection. Basically, what the code injection says is that instead of writing a name or a product ID, let's say in an online retail shop you might have, the attacker would write a SQL query that would actually delete your database or read the passwords or read the usernames or anything that they want to do. In order to do that, they need to understand some kind of information about your databases or data storages and things like that. But the thing is, most people use very standard naming conventions, or there's no additional protection being put in place. So they can doing some trial and error to figure it out what kind of database, what kind of columns and tables you have by just guessing and doing trial and error, and then they can inject malicious code and do damages or steal information from your databases. So there are two type of common code injections: XML injections and SQL injections. To better understand how these injections work, please go and watch this video. It will explain how these, in a practical scenario where someone trying to do a code injection to a dummy or demonstrable retail web application. Denial of service attacks are the attacks where you create large traffic or make large number of requests from particular service in such a way that these service providers get overwhelmed by the number of requests, and then they will not be able to provide service to real customers or real users, because they are so much busy with facilitating the fake requests. So that is the basic idea. And then if the requests are coming from multiple servers, multiple IoT devices, we call them a distributed denial of service. And there are two common ways to overwhelm the service. So you can overwhelm by the quantity of the traffic, And you can also use maliciously formatted packets where the server is trying to understand the packets, and because it could take time, it will slow the performance or crash the entire system. Typically, DDoS attacks or DOS attacks don't steal information or create any security breaches. What they're doing is that it deny access to the real users. And then if you are a financial organization or a critical infrastructure, you will not be able to serve. So you will lose financially, because if you have an online retailer, if you can't sell the products because nobody can browse your system because your servers are so busy with handling the fake request. Or if it is like a security system, analyzing videos or something like that, and then if the servers get attacked, then you will not be able to serve the real users or analyze the real video images and provide the required security by analyzing them. These denial of service attacks can be conducted by using the infrastructure the hacker might have, or they could use botnets to occupy other people's or hijack other people's IoT devices or any other device that has the internet capability, a capability that can request particular server from particular service from a server, and then these bots convert these devices into zombies, which will do whatever the controller says and then initiate attacks. So please go and watch these DDoS attacks and how they work in this video. And also make sure you click this world map. It will take you to an online web page that will explain the timeline of a Mirai DDoS attack and how the attack exactly took place. Since early 2000s, when the Internet of Things term first coined, there have been a large number of IoT devices came to the marketplace, and there was a competition to come to the marketplace fast as possible. So each product can dominate and expand their marketplace without too much competition. Because of this rush, a lot of IoT product manufacturers paid less attention to development of the security part of that. And more importantly, IoT devices are much more complicated than software, other software development projects such as web or mobile or desktop, because IoT has both software, hardware components, different hardware vendors, different constraints in the resources within IoT devices, and then you need to have a lot of different plan A's and B's, because you are not depending on the primary internet connection. You need to depend on what happen if the connection lost. Can you function at least partially if you don't have the full connectivity? So there are a lot of things to think about and handle a lot of complexities. So security become a second-hand citizen within the development process. Because of that, a lot of IoT devices even today have significant security weaknesses. So in 2014, Open Web Application Security Project, or commonly called as OWASP, identified 10 major vulnerabilities in IoT. So over the next few slides, I'll be going through those 10 vulnerabilities. First vulnerability is weak and guessable or hard-coded passwords. So basically, always IoT devices are attached to some kind of user accounts. Therefore, manufacturers need to provide a way to give end users to configure them and connect them and do the initial authentication. For this process, they tend to need to have some kind of password. To make this easier, they tend to have like either hard-coded passwords or weak password or something that can easily type in. So it is less frustrated for the end users during the configuration process, because there are in the configuration process there are a lot of things could go wrong other than the password. So they want to put less stress on the end users by making it easier to have passwords that can type quickly. But then if the end users don't change them, they pretty much stick with the same password. So that is the problem comes in. So the next one is insecure network services. So we have seen that some of the IoT devices don't make them secure, especially the communication between devices. Sometimes they send information in plain text even without encrypting. Sometimes they run different services that are not even essential for the IoT device and make it even accessible over the internet. And many of the IoT devices also have unnecessary ports open, and even the necessary ports are not configured with proper security measures. The next vulnerability is the insecure ecosystem interfaces. As you know that IoT devices are not just standalone devices, they come with web applications or internet web application, mobile application, desktop applications perhaps, and then they connected together. All the information, the notifications are parallelly pushed to different applications. So in order to support these various interactions, they use APIs and other mechanisms. It's build an ecosystem entirely to manage these devices. So these ecosystems could be insecure. So for example, insecure web or backend APIs, insecure mobile account interfaces that could get easily compromised. You can see a lack of authentication or authorization, lacking or weak encryption, or lack of input or output filtering of data. It becomes quite challenging when you have an ecosystem where there are multiple interfaces, different components communicate with each other. Because some of the communications could come from resource constrained devices. So sometimes it may be not even possible to put additional security measures on some interfaces because it takes too much computation. But by default, IoT manufacturers need to provide security mechanisms wherever possible, and then find out secondary mechanisms to add extra security in places where traditional security measures are too expensive in terms of computational resources or not even possible. But at the moment, there are a lot of dangling interfaces that are not secured in each ecosystems. Another major vulnerability of IoT devices are lack of secure update mechanisms. Most of the time, once you bring a device, once you set up, there's no force enforcement for end users to upgrade the system. And then if the end users are not technical savvy, they might not even know what the firmware update means. So there is no secure automatic delivery of updates. And another challenge is that IoT devices are sometimes have very little interactive mechanisms. Like there are no screens or any kind of special buttons to press in order to update. Sometimes you have to do multiple tasks at the same time in order to start these update processes, because If you have one button to everything, like updating or switching on and off, or any other task, then manufacturers probably end up using button pressing patterns, like pressing something for a number of seconds or any kind of pattern. And then these patterns are quite complicated sometimes for end users. So initiating updates could be sometimes challenging, or they might need to bring a mobile phone closer, or maybe even touch the device and then do some task in order to do these updates. So overall, the challenge is to having lack of secure update mechanisms. Fifth most common vulnerability is use of insecure and outdated components. As I mentioned earlier, in order to develop IoT systems, developers use a variety of different hardware, software, different library components, because nobody wants to develop everything by themselves. They use libraries to make things easier. However, because of the immaturity of the IoT ecosystem, these libraries get outdated or unsupported quite quickly in favor of other libraries. So you perhaps a manufacturer or product developer might be shipping a particular product with a certain library, but after sometimes the original developers of that library might discontinue developing in favor of something else. So when you already ship it, then there's no one has accountability or the responsibility to provide any security update for those frameworks, and then they become outdated. The similar things happens for hardware as well, because hardware platforms also get outdated. Manufacturers, the component manufacturers no longer perhaps developing or manufacturing certain components, and then the libraries come with them become obsolete as well. But the IoT devices that they use, these libraries or components will be there in the marketplace as well as with the end users for a long time to come, even though the manufacturers are no longer manufacturing them. Sixth vulnerability is insufficient privacy protection. Especially IoT devices has the ability to gather a lot of personal information, especially about activities, patterns, certain behaviors that could lead to identify individuals. However, the privacy controls provided by these IoT systems are quite naive and not existent at all sometimes. At the same time, the end users also have very little understanding of about privacy and IoT devices and what can an IoT device infer about them. And then the devices are not helping to understand the consequences to the end users as well. So there's a significant privacy protection issues in IoT devices than any other software development domain such as mobile or web. The next vulnerability is insecure data transfer and storage. We have seen even the passwords are being stored in plain text in devices. Encryption libraries are not strong enough in some microcontrollers or devices that have less computation capability. Data communication sometimes happen, especially in smart lighting systems. There are plain text going back and forth, which can be vulnerable to man-in-the-middle attacks. Next vulnerability is lack of device management. IoT devices have a full life cycle from production to someone buying the devices, updating and secure decommissioning, systems monitoring, and maybe repair or restore and resetting. So this whole life cycle is not being properly developed. One reason is again IoT is new, so most of the devices are not gone through the entire life cycle yet. Therefore, the support around that the device management is quite new, because before the IoT, most of the devices people have was like mobile phones and computers. Both had consumer devices as well as business enterprise devices. Because of the enterprise device or enterprise users, the product manufacturers had pretty good, well-defined device management systems where they can be remotely wiped, you can reset, you can decommission, you can completely wipe out the data in a secure way that nobody can access. But IoT, even though there are increasingly enterprise customers, most of the IoT devices are either developed for the particular client, or it is developed for consumers, consumer grade, or they are connected as like add-on rather than mission critical, even if they are deployed in enterprise systems. Because of this lack of enterprise system requirements or enforcement, there isn't any device management built into these systems yet. So over time, usually enterprise customers are the one they would enforce, or they force the device manufacturers or IoT product developers saying, hey, we need this kind of capabilities if you want us to buy your device. Because the enterprise customers would buy the devices in bulk rather than individual consumers, and individual consumers doesn't even know what to ask for. But when this thing happens, when the enterprise customers come and demand certain features, then they will develop that, and then these technologies will be available for consumers as well. But until that become mature, the device support is quite lacking. And there are other issues that when a mobile device is thrown away, or someone moving from older device to a new device, people do understand that mobile devices have information, their personal information. So there is because they see there's a screen, there's a certain personal information is stored, so they understand somewhat that they will need to wipe out the data. But if it is like activity trackers or like smart home assistant, people don't even feel like there's information stored, because there's no screen. They don't pretty much see any information compared to a mobile phone. In a mobile phone, you know that there are email applications, you know that there are SMS messages you can see. So they have end users have some kind of understanding that there are personal information stored in the device. But if the device is like very ubiquitous, people don't understand how much data it has, and then they even might not bother to properly delete and reset the devices before they even thrown away, which has a significant risk in terms of both privacy and security. And previously we discussed the next issue, which is insecure default settings, because to make the configuration process easier, they come up with the default settings in a way that it least burden to the end user. But least burden to the end user means that the security is minimum, or the configuration is minimum, which in long run could create a significant security threat, because the malicious parties know what is the default setting is. So then it is easy for them to exploit these settings and plan a particular attack. And then the last one is lack of physical hardening, which allows potential attackers to gain access to the sensitive information. For example, many of the IoT devices can be easily disassembled, and the storage medium can be accessed separately, because they are sometimes not encrypted and easy to access them. Another problem is that IoT devices are sometimes easy to access than a mobile or a laptop, because end users, when they're using a laptop or a phone, they're very conscious about that is a computational device. There are some data involved with it, so they and fairly expensive devices as well, so they keep eye on them. end users. But IoT devices are ubiquitous and then supposed to be deployed in particular places, like if it is a CCTV camera or a doorbell, or they would be outside deployed, and then motion sensors or any other smart home hubs. Any of these IoT devices are out there, which anyone can actually access them, and because they are cheaper, because they are smaller, and because the end users are not are used to see them as devices that could store data or their personal information, and then there are large numbers comparatively to the mobile or a laptop, people don't pay the same attention that they would pay for a mobile or a laptop. This allows the malicious parties to get access to these devices physically and then use any ports or any other physical access mechanisms to access the data inside them.